Let us discuss pumping lemma in regular language. The pumping lemma for regular language is a fundamental tool in the theory of computation for proving that a given language is not regular. Here is a step-by-step explanation of how to use the pumping lemma. Coming to the theorem, the first point, assume that a language L is regular. This is the initial assumption that we make when using the pumping lemma. Next, choose a string W in language with length greater than or equal to n. This string will be used to derive a contradiction. Identify the pumping lemma length n. The pumping lemma states that for any regular language L, there exists a constant n such that for any string W in L, we can divide string W into three parts x, y, z. The division should satisfy the condition of pumping lemma. The length of x, y is less than or equal to n. The length of y is greater than or equal to 1 or y greater than 0. For non-negative integer I such that x, y raised to the power I z is also in language. By choosing an appropriate value of I, we can construct a new string x, y raised to the power I z that is not in L, which contradicts the pumping lemma. This contradiction proves that language is not regular. Coming to the first problem, prove that the language L equal to a power n, b power n or n greater than or equal to 0 is not regular using pumping lemma. First, we need to represent the language. In this question, they are given the condition n greater than or equal to 0. The limit starts from 0, 1, 2, 3 and so on. Here a raised to the power n, b raised to the power n. N value going to be 0 because it starts from 0, n greater than or equal to 0. A raised to the power 0, b raised to the power 0. Anything power 0 is 1 in mathematics. Coming to the theory of computation, a raised to the power 0, b raised to the power 0 is going to be epsilon. Next limit, a raised to the power 1, b raised to the power 1. So, a, b. Next n value going to be 2, a raised to the power 2, b raised to the power 2, a square a, b square b. Next n value going to be 3, a raised to the power 3, b raised to the power 3, triple a, triple b and so on. The language would be L equal to epsilon a b, double a, double b, triple a, triple b. As per the theorem, assume that the language L is regular. Choose a string W in language with length greater than or equal to n. In this language, we have many strings a, b, double a, double b, triple b. I choose the string triple a, triple b. The formula going to be W equal to x, y, z. So, I choose a string triple a, triple b, W equal to triple a, triple b. Then, we need to find the case 1 and case 2. So, the first case modulus x, y less than or equal to n and second one modulus y greater than or equal to 1. We can divide the string. So, the string is triple a, triple b. We can divide the string W into three parts x, y, z. So, x, y, triple b is going to be z. So, x value y value z value triple b. Coming to the first case, formula going to be modulus x, y less than or equal to n. What is the length of x, y? Here x length is 2, y length is 1. X, y going to be 3. What is the length of n? Length of n means the length of the string. The length of the string is 6. 1, 2, 3, 4, 5, 6. Here 6. N value going to be 6. X, y length is 3. So, 3 less than or equal to 6. Condition true. Next case, modulus y greater than or equal to 1. What is the length of y? Look at the y value, y equal to a. So, length of y is 1. 1 greater than or equal to 1, condition true. In these two cases, both are true. 3 less than or equal to 6, true. 1 greater than or equal to 1, true. Then move to case 3. Formula going to be W equal to x, y raised to the power I z. What is I value here? in this question they are given n value starting from 0, n greater than or equal to 0 means starting from 0, 1, 2, 3 and so on. That is your I value here. So when I equal to 0, W equal to, what is the value of x? We already mentioned the x, y, z value. Here x value going to be AA, y value A, z equal to triple B. Here you substitute the value, x value AA, y value is A raised to the power I, which means your n value starting from 0, that is your I value. So A raised to the power 0, then remaining z is triple B. So AA, anything power 0 is epsilon, here triple B. So AA epsilon triple B, it can be written as AA triple B. So here the string AA triple B, which is in the language AA triple B, the string is not present in this language. So here you mention AA triple B not belongs to L, because the string is not present in that language. Then second limit, when I equal to 1, W equal to x value AA, y value A raised to the power I means here I value 1, remaining triple B Z value. So A raised to the power 1 A. So triple B, here triple A triple B, which is belongs to this language, triple A triple B. Next limit I value equal to 2, W equal to x value AA, y value A raised to the power 2, which means I value 2, Z value going to be triple B, A square means double A, remaining Z value triple B. Here we have 4A, 3 B's. So the string is present in this language, it is not present in this language. So which is not belongs to L. Look at the three answers. When I value is 0, AA triple B not belongs to L. Second, I value is 1, but your string is AA triple B, which is belongs to the language. Next, when I value is 2, W equal to 4A 3B, which is not belongs to the L. Here we got three answers. In these three answers, any one of the answer is not belongs to the language, then your language is not regular. Since the string number of A is not equal to number of B's, look at the answer. Here AA triple B. Here number of A is not equals to number of B's. Here we got three answers. When I value is 0, W equal to AA triple B. Here number of A's and number of B's not equal, because number of A is not equal to number of B's. Here we have 2A, 3 B's, which is not belongs to the language. Next limit I equal to 1. So you will get W equal to AA triple B. Number of A's and number of B's both are the equal. And next limit I equal to 2. W equal to 4A 3 B's. Here number of A's not equal to number of B's. Since the string number of A's not equal to number of B's, but the original language has equal number of A's and equal number of B's. In this answer, if any one of the answer is not belongs to the language, then it is not regular. So therefore the string will not lie in our language. There is a contradiction, because here we got belongs to not belongs to the language, and here belongs to the language, and third one is not belongs to the language. Compare these three, there is a contradiction. Hence language is not regular. Thank you.